So during this session, there is the fifth session of this week. I'll be referring to the two important the issues, that is the concept of inventory flow cycle and the objectives and decisions of inventory control. Now we have dealt with several important issues as an introductory reference to the subject called management of inventory systems. And in any discussions on inventory control systems, we always refer to a condition. What is a condition linked with the flow of materials. So inventory flow cycle in a given system or in a given the manufacturing systems or the service systems. Now this inventory flow cycle is to be presented first, and when you study this inventory flow cycle within a manufacturing system, you can definitely you will come to know what are the positive features of the existing inventory control systems, what are the negative features of the inventory control systems, what are the priority areas in inventory management where you should focus on, and what is the current level of performance, mainly the operational performance, to what extent the operational performance is related to the inventory control systems. So all these the details you will come to know, and when this flow cycle is presented, you feel like getting yourself involved, and you try to improve the situations or improve the patterns of the inventory flow cycle. Now here what is the basic issue involved over here? That means an inventory management systems in any organization involves controlling the flow rates of materials from upstream to downstream process. This we have been emphasizing this. Now this is a concept. Now what you try to do, that means the first exercise you carry out, that is with respect to a manufacturing system which is under study, I need to present the manufacturing systems in terms of the flow of materials, different kinds of materials. The flow rates will also vary. So in terms of the flow of materials within the system across different stages of the system. So obviously the two important the aspects to be looked into. One is the flow rate, and the second one is the level of inventory. That is very, very important. There are two aspects. One is the controlling aspects, and if you look into the controlling aspects, so it will have a direct bearing on the level of inventory. And if you lose control on the level of inventory, ultimately what will happen, that the flow also, or the flow rate, or a particular flow rate also you cannot maintain. So always there should be a balance, because the level of inventory what you have now, there is a limit to this level, because there may be other factors like the capacity which you can have, which you have, and the capacity actually determines the level of inventory. And so these aspects to be considered, and this is to be properly modeled. So this flow rate of materials inventory through the system depends on a number of factors. So the first thing, as I've been pointing out, that first you get this flow, it is to be drawn, that the cycle must be known, and then you need to determine the factors which actually determine the flow pattern of the materials within a manufacturing system. So what are the main factors? The main factors is the level of supply and purchasing rate in respect of raw materials. So ultimately what actually I am trying to represent, that means the relationship between the supply and demand. Is it okay? So there is a demand and there is a supply. Now the supply you get from where? From your manufacturing systems. Is it can you get the supply in instant of time? No. So you have to get a supply, and the rate of supply must be known. The level of supply also must be known at a particular point in time, and this is the rate and this is the level. Obviously, because of many reasons, so they're all the time they're changing, the required rate and the required level. Is it okay? So the level of supply and purchasing rate in respect of raw materials with respect to one particular inventory item, that should be known. So this is the first factor. Second one is the production control related raw material and WIP. That means to what extent at any point in time so the raw material is required, raw material is getting processed, and when it is an incomplete state, it remains in WIP. So how long the raw material remains in WIP or incomplete state? Okay, if the time it spends in WIP form is more, obviously it will have a bearing on the throughput time as well as the manufacturing cycle time. So the marketing rate in respect of finished goods and the level of demand. So the first one is the level of supply, purchasing rate. The second one is the production control, what sort of production control you have. That is control means you are controlling the rate of production or the conversion rate from raw materials to WIP, from WIP to the finished goods. Marketing rate in respect of finished goods and the level of demand. So these are the three kinds of factors. The flow rates across the system balance supply with demand. So this is very, very important. And the typical inventory flow cycle for manufacturing system is shown in the figure. So what is that? So just you keep in mind, and this is just a simple representation. What you have over here, there is a supply and there is a demand. Is it okay? So which system actually or which function fulfills the demand? Obviously it is the marketing one. Okay, which the function of an organization deals with the supply of what? The supply of materials and other purchase parts from the supplier. So obviously there is a purchasing sale or the procurement function in any organization. So now given an item, what could be the supply rate? That means per unit of time, how many units you require. Is it okay? So that the production system is maintained, and you maintain this rate in such a way that it fits to this the output rate and output rate through the marketing cell. Is it okay? Meeting the demand at any point in time or at least during a period of time. Is it okay? So everywhere this flow is determining this flow. This is flow. This flow is determining the flow over here, and this flow is determining the flow over here, and ultimately whether this flow is at any instant of time or any point or in a period of time can meet the demand. So this is your objective. So you can have a relationship between this and this. You can have a relationship between this and this entity, right? Between this one. You can have a relationship between this and this, and between this and this, right? So, and ultimately you check that at any point in time, what is the relationship between the supply and the demand? Supply and the demand. Is there any unbalance? If it is an unbalanced situation, so what are the possible causes? That is to be very clearly understood. And these causes, you need to know what are these causes, and you have to take some preventive as well as the corrective measures. At this point in time, when the causes are occurring, you have to take some corrective measures. But by taking the corrective measures, you will come to know the functioning of the entire flow cycle, or the flow of materials, the functioning that system in depth, and possibly you can suggest some prevention measures, like say to what extent these purchasing departments needs improvement in its performance, to what extent the purchasing cycle or the purchasing procedure needs improvement. Is it okay? There are certain policies, existing policies related to that particular item. Is it okay? Suppose there is some yearly contract, and if suppose this is an yearly contract item, and that's why the flow is hampered. Suppose you can prove it with the data. Obviously, you need to look into these aspects. Now, at other time, what you find that these raw materials and the supplies, at any point in, suppose this is your level on an average at any point in time, is it sufficient, or do you need to reduce this level, or do you need to say even if it increases, is there hardly any effect? Is it okay? So at any point in time, these raw materials and supplies, obviously, as far as objective of inventory control system is concerned, your main objective is to how to reduce the level of raw materials and supplies at any point in time. Similarly, the production control. Now, I have just shown two production controls, but actually, as you know, that the production, the entire production systems, it may have some n number of production stages. So n could be, the value of n could be 10, 20 like this. So from one stage to another. So there is a control mechanism. Okay, so that is basically the production control we say. Is a general the term I have used, but otherwise, there could be the different processes you have. There could be different processes here. Not only this one stage, there could be multiple stages. Is it okay? This is just a conceptual, is the framework, right? And where we want to highlight the important the points. Okay, so again, obviously your exercise could be the WIP, overall WIP. I must have a mechanism with which I can measure at any point in time. At least I will be able to estimate the WIP, okay, overall. Plus, I must have a mechanism to measure WIP at each work center or the production stages. Is it okay? Now, whether this amount of WIP is acceptable to you or not. If it is not acceptable, in majority of the cases, you need improvement. So you need to reduce the WIP. So if you can, if you reduce the WIP, there are many advantages. But in that case, it is to be tuned with, the increment in the production rate or the input rates, the output rate. So somewhere you make a change in some other aspects, some parameters. To what extent the parameter values are affected, it should be clearly understood. And these are the critical issues related to the inventory management systems. Okay, so just I want to just highlight the main point, that is, unless and until your inventory control systems become an online and real-time control system, in many cases, the mathematical modeling, maybe in 20% of the cases, 25% of the cases, the kinds of systems or the kinds of systems you come across, the kinds of conditions you come across. Mathematical modeling very difficult, and even if you have a mathematical model, the real issues you may not be able to highlight in the mathematical model. The assumptions which you make for making the mathematical model may not be valid in a particular instant of time at a particular point in a given situation. So, in many cases, you try to adopt an online real-time control system. So, here the modeling is made in such a way that it helps in establishing an online real-time inventory control system. Okay, so these are the rates. So this is the finished goods level, and this is your demand rate. Okay, so this is the issue. Now there is a concept of so the inventory flow cycle. How would you represent mathematically? This point I was elaborating. How would you represent mathematically the relationship between supply and demand, considering the flow rates of different types of inventory with relevant control parameters? So this is the question I am posing to you. You just make a note, and later on when you will be carrying out several exercises, numerical problems, the case studies and all, I am sure that you will be able to propose a relationship, so develop the relationship between supply and demand. Is it okay? And in terms of the flow rates of different types of inventories. Is it okay? Raw materials, RMOs, then you have the WIP, the finished goods and all those. There could be different the types of control, so that you have to identify. So this is an important issue you need to consider. Now, what I am telling you that there is one particular topic we will be discussing maybe in the later the week, maybe in the 10th or 10th week, we will be discussing a topic called theory of constraints. So at this point in time, related to the inventory flow cycle, I need to bring in, or I need to discuss the concept of theory of constraints. This is also known as the different names are given. Anyway, let us think about this theory of constraints, and to what extent this theory you can apply for streamlining the existing inventory control systems. So what I am telling you, that when you refer to the inventory flow cycle, the concept of inventory flow cycle, the application of theory of constraints is relevant, right? In theory of constraints, later on we'll discuss in detail. Just some important the points I like to highlight at this stage. In theory of constraints, we need to balance the flow rate of materials in different forms among different stages or the resources of a manufacturing systems. Is it okay? That means at different stages or the resources, they are interconnected. So you try to maintain the flow of material in such a way that the overall flow, that means as far as the system the flow over the system is maintained. That means at one level you are getting the supply, and at the same instant of time you are getting the output from the system, and it goes to say the market. That means demand is fulfilled. So there is almost a one-to-one relationship. Okay. So the constant flow, that is the perfect condition. This the balance is maintained. So if you apply theory of constraints, so it will help you in balancing the flow of materials. While you try to maintain a balanced workflow of materials in the system, determining the system performance, we need to look into the relationship between capacity and demand with respect to a particular resource. Now, what you can say that this manufacturing system consists of a number of production stages. Now, each production stages, or the work center or the profit center as you define, right? So it has its boundary line, and what you have, it is considered to be a resource. So any resource you identify, say a capital equipment, what you will have, so you will have it will have its capacity, as well as it will have its demand imposed on it at any point in time. The machine is standing in front of you, that is your resource. I know what is its capacity with respect to a particular item or the component or say raw material, and as well as with respect to a particular process settings. Is it okay? So once it is known, the capacity is estimated. Now you wait for the materials to be processed at that particular equipment. So that means now the capacity is known, whether you get the demand as per the capacity or not. So if at any point in time or during a time period, if you find that the capacity is more than the demand imposed on that particular resource, then you say that capacity at that resource is basically a non-bottleneck. The capacity is more, excess capacity you have. Whereas at the same instant of time you will find that for another resource, is it okay? Another resource, the capacity is less than the demand. So obviously that resource is termed as the bottleneck resource. So in order to maintain the uniform the flow of materials within a production systems, within the manufacturing systems, the first thing you need to know that whether it is affected by, that means entire performance, the system performance, the manufacturing system performance is affected by the performance of the bottleneck resource or the performance of the non-bottleneck resource. So in all the time, because of you know that if the bottleneck resource performs excellently, you will find that there is a corresponding effect, positive effect on the performance of the system. Whereas if the non-bottleneck resource, you improve the performance of the non-bottleneck resource, it is this improvement in the performance in the non-bottleneck resource may not necessarily improve the system performance at the manufacturing systems level. So these resources are classified under two categories, as I have been telling you. One is the bottleneck, capacity is less than the demand. Is it okay? And the non-bottleneck means the capacity is greater than the demand. While you study the inventory flow system as it is depicted by that the flow diagram, we need to increase the flow rate of inventory from a bottleneck resource. Okay, so that is the point to be noted. Inventory control systems are developed and updated in such a way that there is always a scope of improvement in the utilization of the bottleneck resources. Okay, so that should be your focus. That means you may come across the 50 such resources, okay, in your manufacturing systems. Everywhere there is an inventory control system. Now, what will be your priority areas or priority resources, where inventory control system should be the studied first or the assessed first. Obviously, among all the resources that you are dealing with, you first select or you first identify what are the bottleneck resources. So if you improve the performance of the bottleneck resources, that means its capacity is to be enhanced, and the capacity you can enhance only when, that means and capacity is enhanced so that the it can accommodate increased the demand. Is it okay? And there are many ways you can do that. Later on we will study it. What we will find that ultimately the inventory flow will improve, and if the inventory flow improves with respect to the demand on it from that bottleneck, it will have a direct bearing on the the inventory control systems, or the overall materials management systems of the manufacturing system as a whole. So under the theory of constraints, the meaning of the term inventory, that is to be noted. Now here, under theory of constraints, we use a term called inventory, but its meaning is different. The inventory is the amount of money invested in plant, equipment and materials for producing the throughput. Now what is the throughput? The amount of actual sales made. That means you are producing something. Suppose I produce say 1000 units. Now out of 1000 units, I could sell only the 500 units. That means the money which you get by selling 500 units, that money is referred to as the throughput. Whereas the remaining 500 you produce, but that is you produce to stock. So you are not getting any inflow of money. So that is not considered to be the throughput. Now in order to improve the throughput, what you need, the necessary condition is that you must be able to improve the inventory level. So what is this inventory? Inventory means the amount of money you invested, is it okay, to get the throughput, right? And obviously there will be some expenses that we incur, and that is referred to as the operating expenses. So under theory of constraints, there are the three terms we use. One is the throughput. That means the amount of the money you make, and then you have the inventory. That means amount of money you invest, and then you have the operating expenses. That means amount of money you spend to convert inventory into or investment into sales. Is it okay? So the focus is on inventory, but here what is important is that the inventory, what we are saying, that the inventory is idle resource, but idle resource with some economic value. Now you maintain the inventory flow of inventory in such a way that quickly you are able to convert the inventory into the finished goods as quickly as possible, and it is most likely that if the inventory transforms itself to the finished goods form, that means very soon it is expected that you can convert the finished goods into the sales proceeds. So as quickly as possible, you have the raw materials, you have the WIP inventories in your manufacturing systems. So it is most important that how quickly you convert these raw materials, you convert this WIP into the finished goods stage. That is the necessary condition. What is the sufficient condition for improvement of the inventory control system? The sufficient condition is that how quickly you can sell. That means the finished goods inventory, there is a capital tied up, the money tied up. When you can sell the finished goods inventory. Obviously, that money is released from the inventory. So any the inventory control exercises which you carry out, whether it's for the finished goods or the raw materials or for the WIP, the main purpose you must not forget. The main purpose is how quickly, without disturbing the flow of materials within the system, how quickly you can release the capital from this idle resource. And for many a time what happens that if you cannot maintain the quality of inventory, it may so happen that you are keeping the inventory in your stores, but you are not using it. So many a time the main problem the managers they face, even at the corporate level, the how to dispose of the non-moving items or even the slow moving items. So there are three, as far as flow is concerned, there are three kinds of the inventories, three types of inventories you come across. One is the fast moving, second one is the slow moving, and the third one is the non-moving. So the non-moving, there could be many reasons. Later on when we go for selective inventory management, we will discuss this part. But right at this point, I like to highlight one very important point, that is, the non-moving the inventory or the non-moving item may become a dead stock, and the dead stock is a serious problem. In many materials management functions, you may face a situation where 80 to 90% of the time, as a top executive of that particular function, you spend on ways and means, on how to devise ways and means to dispose of this, how to write them off. That means the dead stock item. So ultimately, if the inventory control problem is not adequately looked into, later on, maybe after 5 years, maybe after 2 years, it all depends on what is your inventory level or how many different types of inventories items you are dealing with. You will come to a situation where you will be dealing with excess inventory. So excess stock, it's not the safety stock, it is excess stock, and you have to think of ways and means to deal with the excess stock. Now in this particular the course, I will be discussing these aspects also, but first I will be discussing different types of inventory control models, different kinds of inventory control models, and later on this important issue, that means how do you determine the excess stock, its implications, what do you do with the excess stocks, what are the alternatives you have for the liquidation of this excess stock. This part also we will discuss. So more or less, at the introductory lecture, we have identified several kinds of objectives. We have identified of inventory control systems like elimination of overstock or minimization of overstock, or elimination or minimization of understock, minimization of inventory investment. These are the objectives. You should remember this part. Shortening of production throughput time, assurance of smooth flow of materials. This point is very, very important in different forms, inventory in different forms within the organizational process. So for inventory control of an item, the decision may be of two types. So please keep in mind these two aspects. If mathematical modeling is necessary, first, given a problem, or you get a problem details related to inventory and you conclude that mathematical modeling is not the priority. Priority is to develop an online real-time control system. Thank you.